All right. Good evening, everyone, here in the auditorium in Oeiras, Portugal. And good morning, good afternoon, good evening, good night, wherever you are listening, tuning in from wherever in the world. So today we are kicking off our series of distinguished seminars here at the Space Studies Program 2020. So this is the first of many, many evening events for us, or lectures for some of you that is coming up. So as a aspect of this program, we want public to be completely engaged. This is why these events are open to public and as well as streamed on the ISU YouTube channel. So during this month, July, and next month, you will have a total of 22 lectures, seminars, panels, debates that will be streamed similar to this one. So just to give you a few examples, in the upcoming days, we will be hosting Professor Astronaut Jeff Hoffman. He will be talking about his experiment MOXIE, which is currently on Mars on the Perseverance rover. And then we will have an astronaut panel next week on Wednesday, the International Astronaut panel with Jeff Hoffman and Paula Nespoli. And then just following that, on Thursday, the 7th of July, Jim Green and Michael Benson will be talking about how Kubrick and Clark made a masterpiece, talking about the space odyssey, and many, many more to come. But today, we are starting our seminar series with a very, very timely topic. We have actually talked a little bit during the early lectures about climate change, and now we are looking into how space can help us with all these disasters happening around the globe. And we have a very, very distinguished guest today with us, Professor Paula Bontempi. She is the Dean of the Graduate School of Oceanography of University of Rhode Island. And prior to this appointment, she served as the acting deputy director at NASA Earth Science Division at the headquarters. Her interests include, obviously, Earth, oceans, and space, and remote sensing, phytoplankton ecology, marine biooptics, development of ocean sensors, and many others. So it will be a pleasure and honor for us to listen to what she will tell us about how space can help to mitigate all the things, the hurricanes, the typhoons, the oil spills that is happening all around the globe. Paolo, thank you very much for joining us. the floor is yours. Please give
All
her
right,
a
thank
warm
you.
welcome.
Thank you. You guys are nice. All right. I know what you wanted to do on your Friday night of your first week is sit down and talk about disasters. Okay. I know it's a really uplifting topic. We'll try and make it as fun as we can, more of as interactive as we can, so you can actually see the power of the observations, because I know I stand between you, the bar, dancing, sleeping, whatever it is you had planned for your Friday. So, um, space-based assets have truly revolutionized our ability to not only observe a disaster, but observe the conditions that are leading to a disaster before it happens. And that information has become really critical in predicting the impact of that disaster. So we're going to talk a little bit about a few examples, tell a few stories, and hopefully get some answers from you in engagement. What defines a disaster? Go ahead and yell it out. What do you think? How would you define one? Destruction, human life loss, cost. Excellent. It comes down to all of those things. And what are some of the most major disasters that you can think of? Oh, if we could only observe Brexit from space, we could probably observe the outfall of it. It's any number of things, right? Earthquakes. And I mean, when I show you images in this talk, please, I know some of you may be sensitive to some of what you see. I don't mean by any stretch for these to be a triggering discussion. And I will not feel bad if you want to step out if we're discussing a topic that's sensitive to an area of your home, your loved ones, etc. Okay. So we have earthquakes, we have floods. These are all real pictures. We have wildfires that are proliferating. We have tornadoes that are starting to form and increase in speed and intensity. We have volcanic eruptions. We're getting better at predicting some of this. We have harmful algal blooms, which lead to fish kills. And we have things like hurricanes, cyclones, and typhoons, as you know. And the question for the space-based data becomes, what is the value of this information? Okay. We spoke a little bit earlier in the week, for those of you who attended the climate change lecture, about justifying our observations in terms of cost. What does it cost? Well, if you're an insurance agent, this information is going to be incredibly valuable to you. So let's talk a little bit about a few stories. The Earth is a big place, and we like to divide our disasters sometimes into natural and man-made ones. But with the onset of climate change, it becomes very difficult to separate what's natural and what's man-made. There are a few that can be identified, but I kind of describe it as this burrito that's beginning to fold, right? So what used to be man-made and natural, those are starting to overlap thanks to the changes that are going on in our Earth system. So, observations and science. Let me introduce you to disaster management and policy with an early first example of how this happened. Who knows what the Montreal Protocol is? What's the Montreal Protocol? Very good. Excellent. Do you know what triggered it? Little bit of a hint. Who knows? Correct. So when we first, sometime in the mid to late 1980s, there started to be some studies that showed a reduction of ozone in the Antarctic. And those papers, were batting back and forth. They knew it was happening. They didn't know what the drivers were. Okay. So time marched on and people began to panic. And we began to realize that this was a really big hole in the ozone layer. And we couldn't figure out what was driving it. But we have an animation that looks at it. So the Montreal Protocol was put in place in record time in 1987, was the only environmental edict signed by all 198 countries in the UN. And they did this within 6 to 9 months of actually finding out there was a hole in the ozone layer. Now, what you're going to see in the animation on the left-hand side is the concentration of ozone with the scale on the bottom with the Montreal Protocol as we march forward in time. On the right-hand side, that's what would have happened if we never changed our behavior and signed it. And if you don't know what ozone is, it's in the stratosphere, and it's important for protecting all life on the planet from harmful UV radiation. Okay? So if we had let this march forward, and I think the time goes to 2065, we acted in time to save our planet, and now we have a balanced ozone layer that's recovered. It's monitored every year in a meeting of the Montreal Protocol working groups. NASA sends a member, ESA sends a member, many countries do. But if we had lost all of our ozone, the world would be a very different place. You'd have a lot of impacts. And yes, chlorofluorocarbons were the big driver. That was one of them. But the Montreal Protocol outlawed hundreds or almost 100 compounds that are ozone depleting substances, and that's how they're known. So when the hole in the ozone layer was discovered, of course, politicians gave a huge harumph, right? How could this have happened? What did we do? Whose fault is this? Who can we blame? We have to do something about it. What do we do? Okay, and what I find fascinating about this is this article was in the Washington Post, a major publication in the Washington, D.C. area. A couple of senators and congressmen called a hearing and said, what do we do? What can we do? How do we engage the UN? And as I said, within a matter of months, they had the Montreal Protocol signed and ratified. Now, the Montreal Protocol has every country that's a member with a responsibility to monitor, manage, and report and verify the ozone depleting substances that their country has outlawed or used and what the numbers are and the statistics are. And I love it because they did it on a sliding scale. If you were from a developing nation, an emerging country, you had lower responsibility, a lower financial burden than some of the more wealthy countries. So after they had their hearing, we discovered other things were changing on our globe. And this is a picture of the global land ocean temperature, okay? And this was exactly 30 years later in the Washington Post when they did a retrospective on the hole in the ozone layer. And if you look right here, this is when we discovered the hole in the ozone layer. And what this record showed was that now temperatures are increasing. And temperatures have something to do with the concentration of ozone in the stratosphere as well. So people started scratching their heads going, wow, this climate change thing is really real. So this was a potential disaster that satellite data actually prevented from happening with a speed of action that was so quick that we actually have recovered. The Earth is 100% recovered from this, and we monitor the ozone depleting substances. So that is the potential power when you're having days, and you will have them, where you're so exhausted and tired your teeth hurt, that this is the power of what can change the globe for the better and for future generations. Plus, it's just really cool. Okay, let's tell another cool story. This is the first ocean color sensor that was ever launched, the Coastal Zone Color Scanner on Nimbus 7. It was launched in the 70s. And if you don't know what ocean color is, basically what you're looking at here is the globe. The black is, of course, land, and the colors from cooler temperatures in the purple to warmer temperatures in the red correspond to the amount of plankton biomass, plant biomass in the ocean. How many plants are there? Okay? So we celebrated ourselves. We saw the first global image of what phytoplankton look like. Why are they important? They're the bottom of the food chain. There would be no ecosystem in the ocean without phytoplankton. We looked at the structure of the ocean, and this is the east coast of the United States. Cape Cod is right here, headed up to Canada. We looked at the structure in the ocean and we said, my God, is that oceanographic? Because we know all these textbooks say that things like rings occur and plankton get entrapped in them, but we never saw them before. And then we were able to look at things on a local scale too. Here's a close-up of Cape Cod. This is where New York City would be. And this is the great state of New Jersey, where I'm from. And there's this red feature right here. Do you see it? Okay, when that showed up in the newspaper, a whole lot of people said, hey, what's this thing right here? And they called NASA Goddard and they said, well, it's it's material that's probably phytoplankton. It could be other material because at the time we didn't have the spectral resolution to know if it was living stuff, dead stuff, man-made, natural, etc., because it sometimes looks the same in the satellite retrieval. So the New Jersey Department of Environmental Monitoring sent a boat out. Well, if it's a algal bloom, we better go sample it. We better look at the water quality because this has an impact. And the US EPA, the Environmental Protection Agency, also went out and they sampled it. And you know what they found? One company had been dumping toxic material in this spot for God knows how long. That showed up in the satellite data. So there was a huge court case. They figured out who it was by tracing the compound and looking at the companies who were working in the area. And that was one of the first recorded cases of using satellite data in a water quality and water enforcement and infarction like that. Okay, and it was just happenstance that it showed up in the newspaper and somebody saw it. So, on a local scale as well as a global scale, there is power in our ability to prevent disasters and manage resources for future generations. So, at the time, because of the band set of the coastal zone color scanner, it was only 4 or 5 bands in the visible. Because at the time when we were developing it, that's all we thought we needed to look at plant life in the ocean, right? Materials, you will learn this when you have your lecture on the spectrum. In the ocean, plants can absorb in the same part of the spectrum as color dissolved organic material, other non algal particles, and things like that. So when you get in close to shore, in ocean color remote sensing, like where this is, sometimes it's hard to distinguish what's living from what's dead. In this particular case with the very first sensor, we only assumed it was phytoplankton in a bloom. Okay, and when they got in closer and they sampled the water, there were a lot more phytoplankton there, but there was also toxic material. Does that make sense? So you'll learn that, and Scott mentioned this a little bit this morning about where things absorb and scatter light in the electromagnetic spectrum. You'll get more on that this week. Yes. Because sometimes there are nutrients associated with toxic material, and that can cause phytoplankton to grow. And the whole biomass of phytoplankton in the ocean turn over in 2 to 6 days. So it happens very quickly. They respond very quickly. It's like when you dump a bunch of Miracle Grow on your plant or extra nutrients, and all of a sudden the next day you're like, oh my God, what happened to my plant? The same thing happens in the ocean. Excuse me. Okay. All right. So there are man-made disasters. On the left-hand side of this slide, you're looking at the Exxon Valdez oil spill that happened in off the coast of Alaska. I believe this was 1989, and this, of course, is one of the worst man-made disasters in history. This is the Deepwater Horizon spill that was in 2010. And so we have aerial photographs of these, but what would happen if we could get the information from space? Okay, so let's take a look. Well, it just so happens that at the time of the Exxon Valdez, we did not have satellite-based imagery to look at the area. It was at the onset of when we were just starting to launch them, but we did have aerial photographs. So here's an aerial photograph of what I think is Kachemak Bay. And so it's a little bit bright in here, but if you look at the PowerPoint on your own, you'll see the oil starting to inch towards the town that's located here. And people were panicking. They didn't know how to manage this. How do we actually know where the oil is going to go? How do we actually know where it is? We can see it at the surface in a slick, but what's happening down deep? And we had tons of animal die-offs. This is a seal that's covered in oil, and if you look at the water, the viscosity, it's just a thick, soupy oil. So what did we do? We flew planes to leave dispersant to try and break up this oil, but no one knew the extent of it, how deep it went. How could we figure that out? And one plane looks awfully small against this pool of what's going on in the bay. So we deployed tons of people to the shore, lots and lots and lots of time and resources to try and clean up the shoreline, which is utterly critical to so many things in Alaska, the indigenous populations, the economics of the region, tourism. Do you want to go vacation somewhere where this is happening? Of course not. They sent out ships with booms. I think we know where the oil is. Why don't we try and contain it? And if we can contain it, then we can treat it with the dispersant. And of course, people crawled on their hands and knees with rolls of paper towels, cleaning off rocks by hand, looking for animals to clean off, birds, things that were critical to the ecosystem. And they did this for years. And at the end of the day, there were still very valuable species that were near extinction, that were endangered, that they just couldn't save because of the oil. So, is this preventable? Is the question. And how do we prevent it? 10 years later, researchers went up there and started turning over rocks, and sure enough, even after a decade or 2 decades, the oil is still up there. Okay, and so what's that doing to the ecology of a previously pristine region? Well, when the Deepwater Horizon accident happened, we actually did have satellite imagery, and we responded right away. We have a rapid response team at NASA Goddard whose only job is to provide support imagery within minutes to hours. Typically, this would take quite a long time, a couple of hours to produce, which could be really critical in a disaster. And they sent this off to the response team to show where the oil was going, the extent of it, and they even had information on it at depth. Okay, so this information was critical in allowing people to respond to those events, keep it away from the shoreline, keep it away from the inhabited areas, the ecologically sensitive areas. Out here in the Gulf of Mexico are all sorts of nature preserves. Okay, so contain the oil and move it. That was the power of satellite data in Deepwater Horizon. And we got calls straight through the night when this happened. And we were more than happy to stay up as long as they needed us. Okay. So many of you may have heard the climate change lecture earlier in the week. Let's talk just briefly for a recap for those of you on climate change. Okay. We know the Earth is warming. You've seen this animation. The mean, no change in temperature is in white. I actually changed the scale for you. It's degrees Celsius. We're in Portugal. And as we march on, you've got the anomalies getting warmer in red and cooler in blue. And as you know, as we've talked about, and for those of you who are new, we know the Earth is warming and we know this is intensifying at higher latitudes. We would not know this on a global scale without satellite data. And this comes with a number of implications for disasters and disaster management. We know that of the last 10 years, the 10 hottest global years on record have really occurred in the last 10 or 15 years. We do have some variability in them, but we know that the Earth is getting warmer, and we know that the Earth's global average temperature is warming, and we know a lot of that energy is going into the ocean. So hold that thought. We've seen headlines ad nauseum. Okay, people are panicking. What do we do? What can we do? And we try to calm people down and let them think about the Montreal Protocol, the hole in the ozone layer, the global observations that really brought to our attention. We have the power to do something about this, but we have to act in unison. Remember, all 198 member countries to the UN signed that Montreal Protocol and still uphold it. We need action like that again, and we need to demonstrate that we can act, and we can. So just this week, there was the big UN Oceans Climate Conference just down the street in Lisbon, and I just pulled this one headline from the paper this morning. They confront an ocean emergency at the UN conference. Lots of protesters, lots of fishermen, lots of people whose lives depend on the ocean, whose economics depend on the ocean, are concerned. So there's action. People are ready for action, which is good. Okay, so why does a warming planet matter when we talk about disasters? Well, a warmer climate system means more disasters. So in 2021, there were 20 separate billion-dollar weather and climate disasters shown here in just the United States alone. There's anything from tornadoes to wildfires to flooding to drought to hurricanes, stronger, more intense, bigger hurricanes that are knocking into areas we know are regularly pelted with these kinds of storms. And if you extrapolate this globally, there were a large number of mega disasters that cost more than $20 billion in this 1980 to 2021 period, okay? And these are international. Some of the biggest, Hurricane Katrina, was $182 billion worth of damage. Could we have predicted that and prevented that impact? Is there, and people talk about this, is there something we can do to change the track of a hurricane, to mitigate a hurricane before it comes on shore? How do we give enough warning where we can evacuate areas and get people to safety so the economic impact, the insurance impact is minimized? So global sea level rise. We know that this is happening as well due to the warming Earth, thermal expansion. We know we've got an increase in water in the ocean. Okay, when ice sheets from the glaciers melt, that also increases the level of water in the ocean. And it's not equal everywhere in the globe, but it is increasing. So here's a shot of Miami. During 2020, it experienced what we call 3 to 6 days of sunny flooding. It just so happened that for whatever reason, we had a series of flood events. Beautiful day, no rain, nobody could explain it. It's just sea level rise, it's the impact. That number, given the trajectory of the warming Earth, is predicted to be between 10 and 55 days by 2050. Okay? So if that happens, you have to ask yourself whether the city of Miami in Florida in the US is still a habitable place. The thing is, when we talk about climate change and sea level rise, look at the infrastructure in the area. Okay, look at these tall high rises. Do you think that they can withstand that kind of repeated penetration of water in the ground? Will they be stable? So, yes, it's worrisome for the existing infrastructure. Some people talk about, is this an opportunity to develop new architectural approaches, technology, sea level rise resistant architecture, buildings? What do those look like? Do we need different materials? Some see this as an opportunity because of the living space that we have. So it's an open discussion and it's an area of a lot of technology. Oops. So we do have a sea level rise record. We do this through altimetry. We started out the altimetric data record on the globe by saying to ourselves, we just want to look at surface currents. And then we realized we're awesome. And in the first derivative, we can calculate rate. And in the second derivative, we can calculate acceleration. And so we've got this record of altimetry that gives us relative sea level. And over here, you're seeing the different satellites and the different colors. As we add on to our record, the red line shows you the mean, global mean sea level change. And that just keeps going up and up and up and up. So in toto, since we've been able to identify and measure sea level rise from tide gauges in the late 19th century through when we started to have altimetric data records, we know that the sea level has increased 203.8 millimeters. Now that doesn't sound like a lot, but 101.8 of that happened since 1993. So we know it's accelerating and we know it's increasing. So what's that going to do to our infrastructure along the coast? Oops. Okay. So what are some of the direct risks in disasters from sea level rise? Well, we talked about nuisance flooding. Totally random, no explanation, no rain that day where this is. And if you look over here, this is energy infrastructure for this city. And they're just like, oh my God, I hope this wall holds. I hope it's not porous, right? Because if the electrical system goes out for this part of the city, God knows when they could rebuild it. So this type of nuisance flooding is going to start to happen a lot more. And if we look at New York City, this is after Superstorm Sandy. The reason I point to Superstorm Sandy is because of sea level rise and a warming ocean, the impact in New York City was a lot more intense. So this debris came right down, from the street. Here's the subway system. And the subway system of New York City was completely flooded during Hurricane Sandy. And there's a really fascinating story that I don't have time to tell you the whole thing, but they had to call in a special brand of military to fix the subway system because the subway system in Manhattan is so old that the passageways where the electrical system is laid are about 2 feet by 2 feet wide. And they had to bring in people who are trained to function in small crawl spaces like that. So they had people crawl in 100 meters through the subway system in a 2 foot by 2 foot space on their stomachs to fix the electrical system. Otherwise, they would have had to dig up the whole city. So it seems prudent that those special people aren't always going to be available, and we should plan for better infrastructure or regulate the drivers of what's going on in the disaster. Okay. The other thing that we can do is think a lot about why we have sea level rise, why it's impacting a coastal area so much. We have vegetation that really holds a lot of the sediment and the coastline in place. And what these volunteers are doing are taking these plots of seagrass and planting them. They're trying to replenish the grasses that have been eroded because of sea level rise. A lot of companies are also thinking about things like insurance policies. Should I continue to insure infrastructure that's along the coast? That could be military, that could be electrical plants, that could be real estate and homes. A lot of people are thinking about what are the next steps? How do we prevent this from happening? If we can't replenish the seagrasses, do we have to completely change our shoreline regulation and not allow people to build right up along the coast anymore? What happens to people who have ancestral homes near the water? What happens to people who live in low-lying areas or islands, island nations? So, other drivers. This fort right here is old. It's Fort Beauregard in New Orleans, outside of New Orleans in Louisiana, which is a very low-lying area. I am told, and I couldn't find the picture online, that this used to be all terrestrial. Now it's kind of marshy wetlands that you wouldn't walk in, and here's the remaining road that goes to this fort. So in many countries, Asia, North America, Europe, etc., we've got what's called subsidence. Do you know what subsidence is? It's gradual or dramatic sinking for whatever reason. Okay, there are many drivers of subsidence. The two main drivers are things like pumping out groundwater, which destabilizes the ground, or development, putting really heavy things in areas where the ground is marshy, and that's what happened here. It's a great strategic location. It just cannot withstand the weight of this. Okay, so interesting paper came out recently that looks at subsidence and sea level rise together. And it turns out that subsidence far outpaces sea level rise. And when you take the two of those together, you've got a problem on your hand. It's about subsidence in certain areas is about double the pace of sea level rise. So what you're looking at here is the maximum subsidence velocity in millimeters per year. The red shows you about 50 millimeters per year, and the lower down here in the gold. And if you look around the globe, perhaps where you live, you can see that subsidence is pretty persistent. So we've got sinking and we've got sea level rise acting together. If you look on the lower half, you can see the size of the low elevation fast subsiding zone. In the red, that's about 2,000 square kilometers. In the yellow, that's between 1 and 100. So we've got zones all over the globe that are having an impact. So subsidence plus sea level rise can have a dramatic impact on whether a disaster can occur in an area. Now picture, this is the city of New Orleans, extremely prone to hurricanes. What would happen if even just a Category 1 hurricane came through this area, right? Would we even try and save it? Would we even try and rebuild it? Would it even be possible? Okay. Who knows what city this is? Yes. Does anybody know the problem that Shanghai has been having? Yeah. Aside from that, so in 2015, Shanghai began to be heavily developed. Okay. One of the things they did to to support their big infrastructure, I'm not offended, it's Friday, they have other things they want to do. One of the things that they tried to do when they developed the industrial part of Shanghai is they had to pump drinking water to it. Well, that drinking water came from the ground. And as they started to pump drinking water out of the ground, the city started to subside. And you pile that on to sea level rise, and you have a disaster in waiting. Once the government found this out, in the city of Shanghai, they made a regulation that said, thou will not pump groundwater out from under the city anymore. They'll go elsewhere. So the city of Shanghai and the subsidence associated with it has slowed dramatically to almost a fraction of what it was. So it is possible to make a change and have an impact on a disaster waiting to happen. Yes. I knew you had a question. You had that look. So that is a big topic of discussion. Whether you can replenish the water, and actually, Scott, I'm not sure if you know, but I've heard people talk about this. I've never seen anybody do it successfully. I did some reading online before this. But it is one of those things where people say, can we just put the water back and stabilize the ground? And it's not always that easy, given the water table. Yeah. Okay. So, intensifying coastal storms. So we've talked about the climate changing. We've talked about a warming Earth. We've talked about a warming ocean and the energy going into the ocean itself. This is a schematic, and every time I see this, the hair on the back of my neck stands up. This is Hurricane Maria, which hit the Caribbean a few years ago. And as you can see, the eye right here, and this is the brightness temperature, so this is the intensity of the storm. It went from a category 1 to a category 5 in less than 24 hours. Okay, so that was not nearly enough time to tell the people in Puerto Rico, Dominica, and some of the other low-lying areas like St. Croix that this was coming and to evacuate. They thought, oh, a category 1, we've gone through a million of these. No problem. Our infrastructure will hold. Well, as soon as this happened, while the Caribbean countries were not able to manage accordingly because of the change from a category 1 to a category 5, so this was a doubling of the wind speed from 140 kilometers an hour to 270 in less than 24 hours. Um, People did know they were going to need a lot more relief and help. And so most of the world, especially the US and North America, were able to mobilize quickly. But these areas still have not recovered from Hurricane Maria. Okay, that may take decades, if at all. So, how can we prevent this? How can we think about stabilizing our island nations if we're not going to regulate the drivers of what's going to cause the hurricane? And think about your smartphones, right? When you got your first smartphone and you popped open the weather app, how many days did you get in that prediction? 5. Okay, so old people like me remember 3. And now how many do you get? 10, right? That is a function of a lot of the information that comes from global satellite. Okay, so we feed all that information in, and that is the same that goes into these predictions. So, one of the things we can do, knowing that these storms are going to come, and this is a picture, I know we have at least one Rhode Islander in here. This is Providence, Rhode Island. It has a simulated storm that the modelers have put together. And what you're seeing in the different colors is the maximum inundation in the case of a category 5 hurricane actually hitting the city. So you can see this is all urban infrastructure here. They can notice in the simulation where the maximum inundation is going to occur, and they can think about whether things like hurricane barriers can be built, and where would those go to actually block the water that would be pushed up onto shore to prevent some flooding. And we can take a look at this schematic one other way. This is another view of that same area, and you can see the inundation depth over here. 5 meters is in these dark colors. So this gives the city planners some insight into where the flooding would occur. Where is our critical infrastructure? Where is the rescue squads, the hospitals? Where are the elderly and the children? Who lives along there? What about our ports? This is a critical port area in here. Where are we likely to have materials flushed into the river that would cause an impact to water quality? Do we have any nuclear reactors along there that we have to protect? It allows for cities to plan for disasters like this and come up with that emergency manual that says, this is how we would handle this kind of thing. It also allows them to think about preventative measures. And this is all based on the satellite information fed into a predictive numerical model. Okay. Speaking of water quality, a topic near and dear to my heart, so many of you have asked me about harmful algal blooms and plastics this week. Let's talk about those. I've used this slide background for a couple of lectures now. Do you guys know what this is, what you're looking at? Yes, very good. The last time I asked that, somebody said a Van Gogh painting. So it is true that the patterns of phytoplankton in the ocean, thanks to ocean color remote sensing, look something like a remarkable impressionist painting. The different colors correspond to different types of phytoplankton. The sort of chalky whiteness here is a type called coccolithophorids. They're calcium carbonate. The green ones are typically blue-green algae, And then all of the structure of the ocean. The first time I showed a figure like this in the 90s, somebody said, "What are all the squiggles?" And we said that's oceanographic. It allowed us to see what's happening in the ocean in the first optical depth for the first time in a long time. But we also got a glimpse into the phytoplankton that are there and that we can distinguish different colors in different types. Why is that important? Because of water quality. These are the tiny little phytoplankton that drive that. They're microscopic plant-like organisms that are the base of the food chain. They're primary producers, and they're beautiful. They come in all shapes and sizes. People use them under the microscope and make holiday cards out of them. But they're really, really important ecologically. And they can get out of hand, and they can get out of hand in their growth pattern due to things that we do. And for those of you who have asked me about geoengineering and drawing down carbon dioxide into the ocean by fertilizing the ocean and having phytoplankton blooms, there are pluses and minuses to that. So these happen all over the world. We know since the 1990s, the frequency and intensity of phytoplankton blooms has been growing. We know what causes them. We're not sure how to fully prevent them, but what we cannot control is what blooms. Okay, there are different types of phytoplankton that have toxins associated with them. There are different types of ones that are harmful to consume and ones that are not. So we have harmful algal blooms and just algal blooms. One of the agencies in the US, FEMA, the Federal Emergency Management Agency, is thinking these are in equal footing as a disaster as anything else we just talked about. These ruin people's businesses, tourism, recreation. This is a disaster, a natural disaster, also potentially a man-made disaster. We should compensate people. And you know what the insurance companies say? No, we're not paying. So where's the middle ground? How do we manage a disaster like this? One of the things we can do from space, and I'll put this in motion, is a global view of phytoplankton biomass. And this is merged with the terrestrial biomass. You can see that here. The purples and the blues are lower concentrations, whereas the reds and yellows are higher. And as you watch this march through a monthly timestamp, this is merged CWIFs and MODIS, you can actually see the Earth breathe. Phytoplankton take up carbon dioxide and give off oxygen. And it becomes really appealing to think we could dump a bunch of iron into the ocean and cause an ice age if we wanted to, but really we can draw down that CO2. So when people entertain geoengineering, as it's called, meaning stimulating phytoplankton growth in the ocean to draw down carbon dioxide, you have to ask yourself if that's going to work. What kind of phytoplankton bloom is going to result? And is that actually going to permanently sequester the carbon dioxide? Or are we going to have another disaster? Yes. Oh, the white is ice cover at the poles. I'm sorry, I should have said that. Okay. Interestingly, one of the things a planned satellite mission is going to do is go after phytoplankton groups. This is a model called the ECHO-2 simulation. It's a project done at the Massachusetts Institute of Technology called Darwin. It's an attempt to do an ecological, a true ecological model of our oceans with 80 different types of phytoplankton groups, things that can bloom under different conditions, things that eat the phytoplankton, different types of nutrients under different physical conditions. So the major groups are shown on the bottom here: red diatoms, yellow flagellates, blue Synechococcus, and green Prochlorococcus. And what this model is doing is simulating where they might show up based on some of the other global phytoplankton and other satellite data that we've got. So the PACE mission, scheduled to launch in January of 2024, will be one of the first missions on orbit, launched by NASA, a partnership with ESRON, to actually be able to distinguish who the players on this stage actually are. Why is that important? Because occasionally we have really nasty phytoplankton blooms that ruin our water quality. And this is one from a few years ago. This view from space of this nasty green stuff. Here's a boat going across Lake Erie. Here's a glass of it if you want to drink it. I'm going to go with hard pass. Here's what it looks like in the water. Okay. Somehow, in our typical water quality and phytoplankton sampling, we miss this in Lake Erie. Okay. And so it got into Toledo's water crib and went right into the drinking supply. Well, it just so happened that this was a harmful algal bloom. This was a microcystin toxin, okay, cyanobacteria. And the people were on the TV going, you cannot drink your water for at least 5 days and don't even boil it and try. Okay, that's how toxic this water is. So, how could we have prevented that? And what do we do if we don't prevent it? How do we actually clean up this area and enable people to start drinking their water again? Without the space based data, we wouldn't have that predictive capability. So, not that long after, or before this actually, I was at a meeting where I saw this man, Blake Schaefer from the EPA, give a talk about. He's from the EPA, which is responsible for water quality monitoring in the US. And he gave this talk about I'm trying to use satellite data to figure out how to take your nerdy research and turn it into a management tool I can actually use. And for those of you who go into this field someday, or maybe are perhaps in it, you've got basic researchers who are out there, and we publish these, we pat ourselves on the back and publish these brilliant papers, and they go into journals, and they never ever see the light of day in management. And we call that this sort of chasm of depth. So, how do we take information that we've discovered, that we've gotten from satellite data on a global scale, on a regional scale, and put that into the hands of a manager or policymaker so they can use it? Because the nerdy bits and bytes that we like may be utterly foreign to them. They may not be able to handle it. So, what Blake did is he took all of that information I just showed you and created what's called the Cyanobacteria Assessment Network. This is a global network of several hundred lakes, and he created an app. Whoops, oh God, making a mess, making a mess. So he created an app for it. You can download this to your smartphone. If you see this type of bloom happening, you can put that information in and crowdsource it. It's also a way for managers to have real time or near real time satellite data relayed to them in certain places where they're finding that they may have a phytoplankton bloom. So, a network of federal, state, international, and local bodies all use this information. Okay? So, it is possible to change all of the satellite data that's really valuable for detailing beautiful blooms from space into usable information to prevent disasters for managers and policymakers. And this was a great example of that. Okay, poor water quality in general are impacting us globally. We spend a fortune on this. We fertilize our fields, we feed our livestock, a lot of stuff washes into the ocean. It's gross. Nitrogen input into the ocean impacts our GDP, from what I've read, by about 1% per year. They've also found that people that swim in waters, children especially, that have a lot of nitrogen from runoff in them have a stunted growth of about 20% over lifetime. They also find them occasionally with somewhat lower intelligence. Whether that all can be correlated, I have no idea, but I did read a few papers that pointed to those types of impacts. We do know there's a direct impact on our water quality. Plastics are another huge thing, okay? It's estimated that something like 80 million tons of plastics reach from beaches and shorelines into the ocean every year from different points. Okay, that's a lot of plastics, and this has been happening a really long time. Now, one of the things I just want to comment about here is this is actually a lot of trash, right? So in the ocean, we do have patches of trash. We call these the great garbage patches, but these plastics over time are degraded into microplastics. Now, I heard a talk in Washington by a resource economist recently who said that we all consume one credit card per week in plastics. So, whether that's through the food we eat or whether that's through breathing microparticles in, that was what she said was happening. And when you put it in a context like that, it seems we have to do something about this disaster before it gets worse. So, oh, by the way, this was a picture shown at the UN conference this week. The Galapagos Islands are considered as pristine as they get, right? And this is an osprey nesting there who has, they've either speculated, picked up all this trash out of the ocean and made a nest out of it, or it's stuff that's just washed up on shore and she's using it for her nest. And so here's a totally pristine area that's completely protected where plastics have touched. So there's no escape. All right. So I love this mission, okay? This is called Cygnus. Cygnus was built by NASA. The PI is Chris Ruff at the University of Michigan. And it was to pinpoint the formation of cyclones, the center of hurricanes, a lot better than we could do it. It's a series of 8 microsatellites that use GPS to do it. So the more traditional way of doing this is by using radar. Radar has a problem once there's heavy precipitation, like the eye wall of a hurricane. So this uses GPS, and I'll show you how in a minute. Now, a few people have asked me over the course of the week, have you ever seen a case where some satellite was designed for one purpose, yet we used it for something totally different? Well, here's a perfect example. The way that Cygnus works is you've got the GPS satellite, the specular point where it bounces its signal, and then the Cygnus observatory, and there are 8 microsatellites in the constellation. And if there's no wind, you have smooth water and you'll have a strong signal return. I'm simplifying it for you. If you have a lot of wind, you'll have rough water. Think about wind over the water, and you'll have a weak signal. Okay? And they use this to get some information on what's going on in a cyclone or a cyclone development. What they were able to correlate, now this is highly correlative, so I'll put that caution on it, was that they could detail microplastics concentration. The idea is that because of the microplastics in the water, that could also be driving a signal return that's different. Okay, so if you have a lot of microplastics, it's stabilizing the water, it's fairly calm, and your signal return would correlate with that. So the idea is that in the red, you'd have higher concentrations, and you'd have lower concentrations of the microplastics based on the Cygnus satellite return. Now, again, I caution, it's highly correlative, but interesting. But you could take this one step further, because this is potentially going to allow us to identify areas of high microplastics concentrations, which would allow us to go and enact or enable cleanup activities if they actually work. Yep. So my understanding is they're looking at some sort of shift in the signal relative to the GPS firing. I read the paper, and then I called some of the people who were on it, and I said, explain to me how you separate, the firing of the signal, surfactants, plastics, things like that. And it's not easy to do, is what they said. So that's why I said caution, it's highly correlative. It's like, if, sorry, let me get the pointer. If this is red, right, they're assuming the flatness of the surface of the ocean is driven by high plastics concentration. I think it's also validated by in situ observations. So at the moment, as I said, the system wasn't designed for that kind of return, but they're testing it and validating it in certain areas. Does that make sense? I can give you the paper too and see what you think of it, because I know the oceanographers have had quite a conversation about it, what works and what doesn't. But I do want to show you the potential, because we can design a satellite in the future that actually does this with the target of looking at plastics. So this was the movie they made. And it's not narrated, it's just, yeah, there's no voiceover on it. So they're looking at variability of microplastics concentration in certain areas, and you're seeing the march through time right here. The higher concentrations are in red. And they're speculating, right, that this could be related to what's happening in the northern and southern hemisphere. We don't know this because we've not gone out and sampled, okay? So in January, the Great Pacific Garbage Patch shrinks to its smallest size. We know that because there are ships that transit through it frequently. And then the Northern Indian Ocean, where there's a lot of oceanographic research, also has a correlative area. So does it work? Does it not? Is it a potential? Is it something to look at? Could we dig a little deeper and potentially validate some of this? Certainly with the garbage patches, we know where they've been for a long time because of ships traffic, but what's the potential for the microplastics cleanup? Is it worth looking into? It's an interesting question. All right, home stretch. Anybody here from Tonga or that area? Okay. All right. So we had a recent eruption in Tonga, and I'd like to show this one because this is a very recent example of a direct impact of not only satellite information, but directly into management and relief for the island. So here was the explosion caught by two weather satellites that just happened to be going by, okay, at the time that we had the eruption. And the plume was so big, this is Himawari and one of the GOES satellites. The height right here, here's the troposphere, here's the stratosphere and the mesosphere. This will run. Whoops. Sent the plume, oops, come on, into an altitude that was 1.5 times higher than Pinatubo, which to this point had been the greatest injection of a plume into the stratosphere. So that was crazy. What are we going to do? Has anybody ever seen the animation of the wildfires in Australia? Okay. If you go and you could Google it. Okay. There's a movie done by the Science Visualization Studio at NASA Goddard. I should have put it in here. That shows the wildfires in Australia a number of years ago injected a tremendous amount of material that didn't just stay over Australia. Eventually, it reached the stratosphere and circulated across the globe, and people were seeing impacts of that. Something that injects the plume this high into the stratosphere is also going to have the same effect. So, what could have been a local event is now a global event, right? Because of the transport of that plume. So, what does that mean? There was also a shock wave that went out from the eruption. And what comes with a shock wave? Yes, the potential for a tsunami. It isn't definite, but there are sensors in the ocean that look for this. There are also, as we just talked about, ocean satellite sensors that can look at wave height in the ocean. Can they detect the conditions that would enable or predict a tsunami is a good question. So here's the shock wave, and here was the tsunami prediction from maximum water height. So here was the site of the eruption, and what actually happened is shown in the height of these little triangles right here. So maximum water height was 1.84 meters, and the tsunami wave reached all the way to Japan, which is quite far. They didn't expect that. But it did give the island enough time to actually prepare for the tsunami. We know to look for this now. We've built satellites, we've built models, we've built in situ sensors. When pulled together, become a powerful tool for disaster management. Okay, so this was the last piece. With all of the satellite data, within hours of the eruption, we were, this is actually from NASA, ESA, and JAXA together. They pulled together what's called the damage proxy map. So in this white triangle, you've got this area that's green, which is shown here, a red area and a blue area, which are shown in these colored rectangles. And this shows buildings and infrastructure that are likely damaged from the tsunami, from the eruption, and from other things happening on the surface of the earth as it absorbs the shock. Did you have a question? This was one of the sentinels in Himawari, I believe. Pardon? Oh, SAR, yes. Yes, it's SAR data. Okay. So you've got these predictive maps with the red being the more intensely hit areas and the yellow. These became very handy for the emergency relief and emergency management. They knew exactly where to go to look for potential damage, to look for people, to look for infrastructure that actually needed help. So it was a nice example, a recent example of happenstance of those sensors going over the top at the same time, providing that information into the disaster management node, and providing that directly to the island for relief. This is the part where I want to reiterate something I said on the first slide. Not all satellite sensors are created equal. Some of the bigger ones that some of the agencies and some of the companies tend to launch that are loaded up the size of a Greyhound bus, something like Terra or Aqua that you saw from earlier, can only cover the globe every 2 days. Some of the smaller satellite sensors, like the ones that Scott talked about from Planet, when you have a constellation of 200, you can cover the globe a lot quicker and even many times over the course of the day. The difference is in the quality of information potentially that they provide. So you've got to use the information at your fingertip for the right application. Sometimes a quick look of things that are not climate quality is good enough for disaster management, especially in something as pressing as this. But if you're looking at climate variability and change, you want to think about the quality of the data set and how often you get it. So because I've gotten the question so many times, I wanted to include this. A number of the space agencies together on the onset of the novel coronavirus pandemic put together a dashboard. A number of people have asked me if I've ever seen any impact of the coronavirus, positive or negative, on the Earth. Well, a number of agencies have been tracking this since its inception. So you can go to this dashboard. Thank you to a number of the space agencies for participating. And this is just a snapshot shown here. You can look at different areas that you specify. You can look at any number of economic indicators, agricultural indicators, or environmental indicators. You can load things like air quality. Have we seen shifts in air quality of any sort? Why people were staying home during the first 6 months, year of the pandemic. So you can play with that dashboard and actually take a look. The novel coronavirus, some say, was a disaster. Some say it was very enlightening as to what's happening in our Earth system, and some say both. So there's a lot of information out there. The last thing I just want you to remember is that we cannot look at any one discipline alone. Earlier, I think there were a few talks that talked about the social science aspect of what we do and our role. What I want to remind you of is that those humanities are a lot broader than just the human role. How do we communicate? How do we reach people? How do we show them that we can provide things like disaster relief, management, and support, that we're there to support each other? How do we communicate climate change without offending people or putting them into despair because they'll throw up their hands and say, what can I do? So that messaging and that aspect is actually really important. So I just want to close and say the Earth is a system, right? We can't do any one aspect of looking at the Earth and its function, explain drivers of things like climate change or other disasters without looking at that particular driver's role in the Earth system. So I hope as you advance in your work, your studies, whatever you plan next, you remember that you've got a group around you that are interdisciplinary, just like the Earth. So look at all of those systems and how they interplay. Thank you. You guys are nice. You play overtime? Really? Better than the climate change lecture? Yeah. Is there questions or how do we? Yes. Who? Whoever would like to. Oh, do we have to do the box thing? Okay. Thank you guys for hanging in there until the end. I know it's been a long week. It has to be hard.
Question, but it's also related to what you just presented, is do you, deep inside your heart, truly believe that we can actually get out of this situation we are in right now? Because what you presented, well, that's the first part of the question. And the second part is like, why are we not reacting and being as active as the people were for the Montreal protocol or for the other examples that you presented of really active reactions? Why are we not doing this right now when actually the world has never been in a worse position ever?
Yeah, so climate change can be disarming. It can. But I like to start sometimes with the Montreal Protocol story, the hole in the ozone layer, because the globe recognized the challenge, pulled together, and we literally fixed it in a decade. Now, what are the big producers of chlorofluorocarbons? Do you guys know? Refrigerators. Did we get rid of refrigerators? No. What else? Hairspray. Do we get rid of hairspray? No. Okay, so what it allowed and facilitated is innovation. What's the alternative? So I know with everything I am that we can get out of this. I know it's not too late. I know it because take a look at the dashboard for the pandemic, right? We saw air quality improve in a matter of months. That we saw water quality improve in a matter of months. All it took was all of us staying home and driving less. Well, maybe we don't have to drive less, but maybe we have to think about infrastructure that's different. Maybe if there were incentive for people to buy electric cars, tax breaks, centralized transportation in cities, that was better. It's terrible where I live. You know, I have to drive. I have no choice, but you can, you know, some people have the luxury to choose what they drive. Good food that's not shipped from all over the globe. Think about that. We can affect that. I believe with everything I am that we can change this and reverse it.
Thank you. That's really helpful, actually.
Yeah, whoever would like to go next.
Hi,
Oh, okay, sorry.
so really fascinating talk. Found it really inspiring. So thank you so much. So my question was about the Deepwater Horizon incident, and more specifically, at the moment, what level of evidence is required to prosecute companies that are responsible for pollution and environmental damage, and whether or not we have to use ground verification sort of data sets. And I just wondered what the state of the art is in that at the moment.
Yeah, it's a good question. I'm not a lawyer and I don't play one on TV, but the little bit I do know about Deepwater Horizon was it was very clearly that well. Okay, so there was no hiding it from where the oil was coming. The question I think that people probed was there negligence as a driver, right? That's I know we have at least one lawyer in this room. I don't remember where she's sitting, but you know, that criminal negligence piece is what they argued. Was it just an accident? Was it intentional? Was there maintenance that wasn't done? That was the part. I mean, certainly British Petroleum paid a hefty fine. Some would argue it wasn't heavy enough. Some would argue just because we can't see the oil anymore on the surface doesn't mean it's not still somewhere, right? It was a lot of oil that spilled. And as with the Exxon Valdez side by side to it, when is the next one going to happen and are we ready? At least we have satellites to sort of identify where the spill is going. We can evacuate those areas. That's a tool we did not have during Valdez. Yeah, I'm sorry.
Hi, no, I echo the thanks. It was really a really cool lecture. Thank you. I've got a question around multi-use satellites. So as constellations grow in low Earth orbit, do you see any potential for capitalizing on all this new orbital infrastructure with all these new unique orbits, you know, essentially becoming a 2-for-1? And being able to also operate not only as telecommunications platforms, but also potentially as Earth observation platforms with very kind of lightweight, minimal tech that can help fulfill the greater reaction times to these disasters.
I do. I think we can. Like I said, it never ceases to amaze me how we can squeeze blood from a stone. Cygnus was never intended to do anything like ocean plastics. And while it may not be perfect, it's interesting. ICESat 2 was never meant to do seafloor bathymetry, but we can do it. I've seen other satellite retrievals that are mind-blowing, where you're like, you know, I think we just did a paper in Nature a couple of years ago, a few of us, that used Calypso data, the Calypso sensor, to look at migrating zooplankton in the ocean. And we published it in Nature, you know, and so I think the sky's the limit on what we can do. What would be better is to take a look at those numerical models for disaster prediction. I'd like to see the 10-day weather prediction on this become hurricane prediction, HAB prediction. What variables do we need? What properties of the ocean, the earth, the atmosphere, the ice do we need to actually enable that? And that's where we need to go after observations. Yes.
Hi, as everyone else has already said, thank you very much for a very informative lecture. The question I wanted to ask was regarding the International Disaster Treaty. It's obviously a large piece of legislation that's been used quite a lot recently. I was just wondering if you could comment on your personal perspective of how successful it's been, essentially. And
I'm embarrassed to say I'm not sure I know which you're talking about. I'm not a disaster expert by any stretch. Is it a UN-based one?
it's related to the UNDRR.
Okay. Yeah, I don't know enough about it to comment. I don't want to be on the record on camera, but I'm certainly happy to talk to you about it offline. It's just
Perfect.
not my area.
Thank you very
Sorry.
much.
Do we use satellite data in code for evidence against man-made disasters?
Yes.
Yes, we do.
Yes, but let me tell you what scares me about this. So all of the things I showed you were in the interest of disaster relief and management. I had one situation with Deepwater Horizon, I believe, where I got wind of somebody going to testify in a legal case with MODIS data with them. And I thought, holy crap, they're going to put this on the stand. They're going to ask for what I would ask for, which are errors or uncertainties associated with our observations. And they're going to drive a truck through any argument whatsoever. The question is, do we understand the error and uncertainty with our observations, to be able to withstand a legal trial? I'm not sure we're there yet. We think and talk a lot about it, at least in my days at NASA with all of the PIs there. But that's another level of time and investment. It's hard to get our arms around error. We also know a lot, and we've become a little bit gun shy about putting error bars on our observations because we don't want people to see they're this big. The thing about that is, I tell my students now, don't be afraid, okay? Because the way that we reduce those error bars is by knowing we have them and making the observations and the investments that we need to reduce them, right? So think about it in the context of, and I'm sorry to use this analogy, but cancer research, right? If you knew what the drivers of something were to predict whether you were going to get breast cancer or not, you would want to invest tons of money in that. You wouldn't want that to happen. So how do we go after that like the medical industry? It's the same kind of argument.
Hi, this isn't a question. I was just going to say the talk was really good, and especially this presentation is fantastic. Like it's such a visceral so it's such a I guess visceral presentation of how meaningful this data is for decision making. So yeah.
So the question becomes, going back to our lecture earlier in the week on climate, what's the economic value of these data? How do we put our arms around that number, right? All of these resources at stake. Some of this, like Cygnus, a few $100 million investment, and people are like, you want another $500 million to build a what? And you go, well, wait a second. What can we do with it, right? There's a lot of value there, but how do we calculate that out? I'm kind of obsessed with that. Yes.
Hi, thank you for the presentation once again. Would you say that, would you know if there are any open source projects in which one might contribute towards coming from an engineering background?
I'm sorry, let me make sure I understand. Open source data products?
Data projects, or if there are any ongoing research projects that are open source and available for volunteering, basically.
Yes, there is an entirely new initiative, is my understanding, at NASA. There may be at other agencies as well, like open source, open data, really being serious about sharing code, sharing model input, sharing observations, data products. That is a very popular thing. So I think others here, like Jim Green, might know more about this at NASA. But if you look in the Earth Science Division, they just hired a new program manager to sort of take the whole open science effort and just bring it into the new millennium. So that is spinning up very seriously. It's nice of you to volunteer too. Yes.
Hi. Yes. My question is more on the Arctic Circle. Do you think, from your own opinion, that there's a certain desire for inaction because certain countries in that region maybe prefers that the Arctic melts so that they can access the resources there and also the shipping routes?
Yeah, it never ceases to amaze me what people want for economic gain. I think you guys did a word cloud on something like what's the biggest barrier to space 4.0 this week, and it was greed was the big one. Never underestimate the power of money and control. What do people with power want? More power, right? So control, access, things like that, strategic stuff. That comes out all the time, right? As drivers, I'm slight on the other side of the coin there, and I'd like to see things managed sustainably. So if we can't fix the Arctic opening, the waterways, the pathways, the trade ways, we have to at least manage the resources sustainably so we don't have geopolitical conflict like that. Yeah.
Hi. So you've mentioned this a couple times, both today and then also in your original lecture about uh, like the humanities and communication and how we like spin things to the general public. So I was in elementary school in Houston when the BP oil spill happened, and I just wanted to know what your opinion on of like the stuff that we call things. So an oil spill makes you think like knocking over a glass of water, but 200 million gallons of oil was dumped into the Gulf of Mexico.
It's a great question. Looking for analogs that people can get their head around is important. Like, let me give you an example I hear all the time. When we talk about how much energy the ocean takes up, people cannot get their head around that. Like, what do you mean how much energy? And I always hear this one senator in the US say, well, it's a zettajoule. And you're like, what's a zettajoule? I bet you're all going to look it up if you don't know what it is. It's 10 to the 21st joules. Okay, that doesn't really help me either. That's a lot of zeros. What does that mean? It's the equivalent of 5 to 6 atomic bombs each second for 24 hours. Now you understand what we're talking about, right? So looking for ways to give people some sort of analog to the volume, 200 million barrels. What does that mean? How much is that? Is that the volume of, a quarter of the Gulf of Mexico? How many bathtubs would it fill? That kind of thing. How many times have you heard people liken distances to how many times you can go around the Earth? So that is kind of how we have to bring things down to people's level. And you're going to laugh, but I have a 93-year-old mother, and every time I'm going to put like a press release or something out, I'm like, Mom, can you read this? And she'll be like, I don't understand this at all. And if she can't get it, my old boss at NASA used to call it the Lucy Bontempi test. Hi, Mom. She would be like, could you just like read this to your mother? And I'd be like, Mom, I'm going to read this to you. And all joking aside, like have somebody who's not in the field, read it. Does this make sense? Can they picture this? Because that's the same tact you have to use with politicians and policymakers. You will lose them, and you know this, in 3 seconds. They will tune out. They will be elsewhere. And that elevator speech you prepared so carefully, that opportunity's gone. Thank you for pushing forward on it.
Hi, thank you so much for your lecture. As I said, it was great for the climate change one, and this one absolutely same, knocked it out of the park. Mike, I have 2 questions, more economic space. One, what is the budget that's currently being allocated to this kind of, disaster management, let's put it this way, and like a percentage-wise? And 2, are there any is there a push in the commercial sector to aid this, like as we see, with SpaceX for the space applications, basically. So yeah, thank you.
Yeah. As far as dollars, I think it's hard to predict. I'll tell you why. When you build something like Cygnus or MODIS or whatever satellite sensor you're talking about, it's built with multiple communities in mind, multiple retrievals. There could be 250 data products coming from just the MODIS sensor on the Aqua platform. And they could cover land, ocean, atmosphere, cryospheres, hydrology, solid earth, So it's hard to say that any fraction of one of them, we used to get asked this question a lot at NASA, they probably still do. You just say, well, I want to say the whole platform at $1 billion, I'm making this up, is used for disaster management, but it's also used for carbon cycle and weather, right? So partitioning that out can be a little bit hard. There are investments in research, in the research and analysis piece at agencies like NASA and Earth Science that are dedicated to answering questions like, how do we improve the prediction of, the tsunamis that may come from volcanic eruptions or subsea eruptions? So how much that is difficult to tease out in agency budgets. It's billions, if not more, tens of billions, hundreds of billions across the United States government for sure. And your second question, forgive me, was on the...
Are there any commercial actors?
Yes. Okay, so when a disaster happens, I often now see in the newspaper or online commercial entities jumping in, whereas they may charge for imagery as soon as a disaster happens. It's in our nature, and I have to believe this, to start helping out. So I have seen some companies come forward with quick browse imagery to sort of help disaster relief management. I think there's a real interest in doing that.
All right, thank you very much.
You're welcome. Pardon? Yes. Yeah.
Hi. Yeah. I wanted to express some, I don't know, disagreement, discomfort when you gave the Montreal Protocol example. There were other examples during that area, like banning lead from fuel or tackling the acid rain. Those are way easier problems than global warming.
Yes.
Like it was just banning a few gases from the refrigerators and the hairspray, whereas tackling the greenhouse gases, we have to fundamentally change our way of life on every aspect. And now blaming saying, oh, the big oil companies, they don't want that. They didn't want to take lead out of the oil either, but they had to. So like the comparison of, I would like to elaborate on, like, you know, the comparison of saying, oh, when we all hold hands and make the decision to within 60 months we can ban CFCs. Yeah, but that's much easier than reducing greenhouse gases.
Is it much easier? Because there are almost 100 ozone depleting substances out there for which they had to find substitutes that quickly. Now, I hear you. I will say one of the ozone depleting substances is 2,000 times more impactful to climate change and global warming than carbon dioxide, because CO2 is an inert gas. We just produce a ton of it. And remember, that's 91% of the greenhouse gas problem. So, and 91%, 91% of CO2 comes from fossil fuel combustion. So if we just started with our cars, okay, if we just started with our cars and started to make, you know, electric cars more available, cheaper batteries, you know, you could go, instead of 300 kilometers on a charge, you could go 1,000. How hard is that to do? I have no idea. I believe an impact in an area like that will have a significant reduction in what's happening in our globe fairly quickly. I hear you, you know, about the comparison with the hole in the ozone layer. But there were some serious fixes that had to be found for some of those compounds. Because as I said, we still have refrigerants, right? We still have hairspray. We just sunset the aerosol aspect of it or found an alternative. So I'm not expert enough to know the numbers off the top of my head. There are those that probably are, but it would be interesting to dig into the resource economics of that. I agree. It's a good point. Yes. And if one of the other lecturers or instructors knows the answer, by all means jump in. I don't want to mislead anybody.
Okay. Hello, and yeah, I just want to echo thanks again for your time for your lecture this evening. So my name's Hannah, I'm from Australia, and one thing I just wanted to touch on was, of course, we had the disastrous bushfires in Australia a couple of years ago, and one of the things that some of my contacts from the Australian Space Agency were saying was that at that time they were inundated with, you know, so much generous offers of data from all over the world, commercial entities, other space agencies, and the biggest problem that they had was the ability to analyze, interpret, and, you know, act on that data in real time. And it was a really big moment of realization for them that that was actually where they needed to invest, you know, their time and resources in, was data analytics rather than, you know, the technology itself. And I just wanted to understand your perspective on that, particularly for disaster
I am
management.
not surprised at all, because, you know, maps, I don't know if I can go backwards, but maps like this come from lots and lots of engagement with stakeholders. What do you need, right? And they say, oh, we need, you know, to know where the tsunami is going to hit, and they'll get this complicated explanation, when really they just need to know black or white, yes or no. That's all they want, right? Do I deploy resources or don't I? I don't have time. Do I evacuate or not? What if, you know, we evacuated all of Tonga and that never happened, right? That one island, that eruption at the end. What if we went to the wrong place? They just need, I find, they just need that binary, yes or no. Which way? Are we going to have an algal bloom or aren't we? Don't tell me where it might be in probabilities. I'll tell you if I need that. I just need to know, are we in trouble? That's what I've seen over my career. So sometimes we make it a little too complicated, but then working with the stakeholders, that engagement is really important.
Thank you.
So hello, and thank you very much again for all the amazing information you shared with us today. I think the background in my question is quite in line with what Anna just said, and it's about a little bit the international cooperation around this, because I mean, we saw amazing, modeling about how the floods, for instance, it might hit U.S. cities, but what about other countries with less capabilities than what you showed right now? And I mean, I know that there is, for instance, the UN Spider, which is acting mostly on capacity building, but is there any other system that you enact in case there is a major disaster somewhere else in the world? And how the space agencies or, I don't know, private actor indeed interact to provide images in case of a major disaster? Thank you.
Yeah, no, it's a great question. So just looking at the UN Oceans and Climate Conference that's been happening this week, I'm seeing lots and lots of input by philanthropy, by NGOs and mass, small ones, big ones, startups, small companies that are coming and going, I think we can help with the plastics problem. I think we can help with disaster relief and management, and they all have expertise in different areas. So there's a lot of, in fact, sometimes reading the list of people that are engaged, I'm almost overwhelmed. Where do I go for help if I want help, right? Where do I start? And how do I work that network so I get what I need and then I find the right partner? So I think that's actually super important. I don't have the right answer for you, but there are a lot of people engaged. As far as the satellite data, my brain tends to be US centric sometimes. So my first thought is NASA, NOAA, USGS, where do I go? ESA had, I have to say, when they came up with the Sentinel concept of that constellation, utterly brilliant, right? They have every right to go back to the ministerial and ask for double the billions of euros that they got the first time, because they're really thinking about the applied piece. The one thing that I think NASA does really well is just complete exploration of our home planet in every aspect of it. And in some sense, I think when I started at NASA, I would say, well, applied science, we had a small section of earth science that did that. And I felt like, we don't have the responsibility of regulation and management and policy making. But I certainly felt at the tail end of my career in 2020 when I left that had really shifted. And we all have that responsibility. So my hope is that from within, the space agencies are thinking not just my backyard, not just my lands in my home country, right? But what can we do as a network of agencies and in commercial partners? So I think we're headed in that direction. The coordination, I think, is going to take some time. Yeah.
Hi, thank you. My question is regarding the money. If someone tried to make regulation to enforce, for example, oil companies and so to pay for satellites, because you saw how can it help to contain and stuff like that. So oil drilling and companies like that, to make them to pay for special satellites for security measures, to be like an alarm in the sky or something like that, but particularly, and not just the government satellites, to be half commercial, half
yeah, maybe one that can actually, a lot of the imagery you saw, those aren't sensors that are developed for oil detection and quantification, right? So that's a good suggestion. Maybe the next round is part of the penalty is an investment in something that can be a global or a regional sensor. It's a good idea. I mean, it certainly is a fitting punishment, and it's not a punishment, right?
All right, Paula.
Oil detection OSAT. I don't know what that would be. That would be really cool, though.
So such a brilliant lecture and such thought-provoking. So in this class, as you very well know, I mean, we have engineers, policymakers, economics people, business people. So I think at this stage, when we listen to this conversation, it's already too late to say, oh, it's increasing the awareness. I mean, that's way beyond. Now, this is really time for you, especially sitting in this class, to really take this information, combine it with the rest of the information that you are receiving, and really thinking about how to act. I mean, Paula mentioned it several times in her presentation. Somebody needs to really take this information and put it in the hands of decision makers, policymakers, and you are the correct people to do this. So the entire summer is ahead of you. We will expose many other things on top of you, but I think this was a perfect start. Once again, give a big shout out to Paula.
Thank you. It's been a pleasure. It's been a pleasure, you guys, and an honor, and your questions are phenomenal. So I know you're on the right path.
And just to close, 9:30 Central European time, we will be back online with astronaut Jeff Hoffman, and he will be talking about the MOXIE experiment that he is the deputy PI on the Perseverance rover currently working on Mars. Until then, have a great weekend and see you on Monday. Take care.